All right, so just more examples of matrix multiplication. So we're supposed to find the indicated matrix product if it exists. So we're taking A times B, so a 3 by 2 and a 2 by 4. Well, is that going to work? Well, yeah, because you have 3 by 2 and 2 by 4, so the 2's happen. And so what's going to happen is you're going to end up with a 3 by 4 matrix. And so we have C, it's 3 by 4 cost. And so then you have to do all the pieces. You have to take 2 times 1 is 2 plus 2 times 1 is 2, so that's going to be a 4. And then 2 times negative 1 is negative 2 plus 1 is going to be negative 1. And you just keep doing that for all these different pieces here. And then you're going to have to simplify, add all the things together. And as you can see, 4 minus 1. And sometimes writing it out is a little tedious. I think if you can move your fingers and say, okay, well, I'm going to take 2 times 1 is 2, plus 1 times 2 is 4. That's going to give us something. Then 2 times that's going to be negative 2 plus 1 is going to be 1. And then, if you wanted the last position, that's going to be a minus 1 times a 1. That's going to be minus 1 and 0. So that's a minus 1. And, that's what we get. So I think, if you need to write it out, that's fine. But sometimes it gets a lot tedious when you do that way. And so it all depends on how you follow it and how you can do it. All right, so let's look at this one. B times A. Well, here we have a 3 by 2 and a 2 by 4. So guess what? That 4 and a 3, that's not going to be defined because we have the 4 is this way, so it's going to be, and that is a 3, and so we don't have a thing because those have to be equal. Now, the two parts, if it worked, then we'd have a 2 by 2 at the end, but the 4 and a 3, that's not defined. So we're done. We don't even have to multiply. That's why I say sometimes you'll have a problem, and they might say, take AB plus 4BA minus 7AB. And so you're working along, you work this piece, and so you've already got that. So, okay, well, now I can do minus 7 times it and have that piece. And then now, as I'm working this one, I'm like, oh, it's not defined. So before you start, make sure each piece is doable before you actually do any work, because sometimes it won't be doable. And so because that one's not doable, the whole thing's not doable. So then you're done. Okay, so that's kind of a key reason why, because we saw that this one was doable, but this one's not. And so if you had to do that whole thing, that middle piece not being doable makes the whole problem not defined. All right, so find the indicated product if it exists. Well, here we're having C times D. So this is a 2 by 2 and this is a 2 by 2. Well, those two are equal, so we're going to end up with a 2 by 2 when we're done. And so we multiply. So 2 times 1 is 2, plus 6 times 3 is 18. So that'll give us 20. And just keep working your way down and you get the following matrix. Again, just working your way through it, with your fingers works sometimes. Otherwise, if you need to, go ahead and write it out and then you can get the final answer that way. What about DC? Well, DC, guess what? These are the same. It's a 2 by 2, and that's a 2 by 2. So those are the same. So we're still going to get a 2 by 2 out. And so we're going to multiply it out. But look what happens here. We get a zero matrix. Okay. So that's kind of a cool thing. Sometimes you'll get a zero matrix. Sometimes, most of the time you won't. But in that case, we do. All right, what is EF? Well, E is a 1 by 3. This is a 3 by 1. So we're going to get basically a 1 by 1 when we're done. So we're going to take 2 times negative 5 is negative 10, and then minus 6 is 16, and 0, and so we just get minus 16. Okay. Now, probably going to ask for FE. Again, FE, well, that's going to be a 3 by 1, and this is going to be a 1 by 3. So guess what? We're going to get a 3 by 3 here, and so it's going to be a big matrix, and all we have to do is multiply one piece. 5 times the 2, negative 10. 5 times negative 5 times negative 3, 15. 5 times 0 is 0. And just work your way down through it, and you get a 3 by 3. Okay, so sometimes, it's a real simple thing. You just have to multiply two numbers together. Sometimes you have to add a whole bunch of pieces together to get it to do that one position for that one element. What about a squared? Okay, well, a times a basically. Well, a is the 3 by 2, and a again is a 3 by 2. Well, guess what? That's probably going to be undefined. Okay, so that's kind of a nice thing again. Just checking those things out before you even try to start multiplying and you find out it's not defined. What about C times C? Well, this is a 2 by 2 times a 2 by 2, so this will work. And so writing it out, we'll have 2 times 2 is 4, and then minus 6 is going to give us a minus 2, and then we'll have a 12, minus 18, so minus 6. And so we can work our way through it, and we get our C squared, which is just C times C. All right, here we want to find A, B, and C such that we have this final thing here. Now, I don't know why they didn't ask for D, but that's another story here. All right, so what we can do is we're going to go ahead and multiply on the left. And so we'll have 2A, and then we'll have minus C. Then we'll have 2B minus D. Then we'll have 5A minus, and then plus 3C. And then we'll have 5B plus 3D. So that is going to be on our left. Then on our right, we have the minus 6, 17, 7, and 4. So we just set that equal to this piece equal to that, this piece equal to that, this piece equal to this, and then we can solve all the different items. And so basically we get a system of two equations in the variables a and c, and the second system is in the variables b and d. And then we're going to have to go back to using either substitution elimination, Gauss-Jordan elimination, or something to be able to find our solution. So we'll leave that up to you, but that's kind of what you would have to do there. You'd have some equations you have to simplify and get to the point where you could solve them. So, you could eliminate these pieces, eliminate something here. Then you'd have A's, maybe you could solve for here, B's you could solve for here, and go from there and solve A and C and B and D. All right, let's stop there and we'll come back for more.